Good morning, everyone. So today we'll discuss one more part of this chapter, that is relations and functions, that is functions. So in this chapter we'll study about types of functions and their verification, all those things, and composition of functions, and we continue with that. So before going into types of function, we should be very clear what do you mean by function. So I hope you remember the things which we have studied in our first year. That is, what do you mean by function? A function is a mapping, correct? It is a relation. A function is nothing but a relation from x to y. Okay, it is a relation from x to y where every element of x, that is every element, has a single output in y. Okay, that is every element in x has a single image in y. Only then the given relation is said to be a function. So function is nothing but it is a relation where every element in set x has one image in set y. Okay, for example, suppose I have two relations. Okay, 1 2 3 1 4 9 1 2 3 and 3 4 5. Okay, suppose I have I'll map the first one. This is first example, this is second one. Okay, suppose I have something like this, and if the mapping is this, can I say that the first one is a function? Yes, because every element in set x, this is set x, this is set y, every element in set x has only one image in set y. Every element in set x has only one image in set y. So this first example is a function. Suppose the second example, if I map it in a way, okay, whether this is a function? No, because you can see that one has two images in set y, correct? One has two images in set y and 3 does not have any image. So in order to be a function, whereas this is a relation, okay, this is a relation, but it is not a function because you can see that one has two image. In order to be a function, that is the input. If we say that is f of 1, I have here it is equal to 3, also f of 1 is equal to 4. So this is my input and this is my output. So for every input, I should have only one output. It should not be two outputs. Okay, so only then a given relation is said to be a function. I hope you're clear with the definitions of the function, because further we won't discuss about what is function, but we'll discuss types of functions. Okay, so we'll take one more example. That is, suppose I have something like this. So whether this is a function, that is example 3, whether this is a function, can you identify whether it is a function or just a relation? So what is the definition? Every element in set x should have one output in set y. That is, whatever elements you have in the first set, it should have one output in set y. So what is f of 1? F of 1 is 2. What is f of 2? F of 2 is 2. So you can see 1 has only one output, even 2 has only one output, and 3 has output, 4 has output. That is only one outputs it has. So this particular relation is also a function. Okay, so in order to be a function, what is the necessity? Every element should have only one output. You can see 1, f of 1 is also 1 is 2, f of 2 is 2. Okay, so that doesn't mean this is not a function. Function means the elements in set x should have only one output. Okay, so the example 3 is also a function. I hope you are clear. So now we'll move on to types of functions. So today in this session we'll discuss only about one function. One function. So what do you mean by one function? To be precise, if we go with the definition, it is like f is a function from x to y, which means you have to take elements from x and it should be mapped to y, is said to be 1 if the images of distinct elements of x under f are distinct. What do you mean by that? Suppose you have a function. What does this mean? It is a function. First of all, if it should be a function, it should have, every image should have, every element in set X should have one output, only one output in set Y. Okay. So that is necessary. What is the extra thing? Distinct elements, images of distinct elements under F are distinct, which means 1, 2, 3, 4, 5, 6. Then only this is called as 1, 1 function. That is, one element in X can go to only one element in Y. Then if you take another element, it should not go to the same element. It should go to different element. That is, the images are unique. You cannot have two elements from X having same image in Y. Only then the given function is said to be 1, 1. I hope you are clear. One element in X should have only unique image in Y. No other element in X should have the same image. For example, if I have 1, 2, 3. So this is not a 1, 1 function, because one element goes to many, this is not a 1, 1 element, because many elements goes to one element, correct? Here you can see one element goes to 1. One element goes to 1. One element goes to 1. But here it is many element goes to 1. So in order to be 1, 1 function, what is the necessity? That unique distinct elements under distinct elements in X should go to distinct element in Y. That is, images are distinct. Okay. So when we prove this in a mathematical way, we say it as, suppose if the images of two inputs are same. Okay. Suppose x1 and x2 are two elements from set X, that is x1 and x2 belongs to X, and if you can find that f of x1, that is their images are same, then in order to be a 1, 1 function, what you have to show? That those two elements are equal. Okay, those two elements are equal. Only then we say that the given function is 1, 1. Okay, I hope you are clear. One more 1, 1 function. 1, 1 function means that distinct elements from under set X should go to distinct images. That is, 1 goes to 1. It should not be many goes to 1. Okay, 1, 1 function. If it is not 1, 1, if it is a kind of function of this, that is many goes to 1, then we call it as many 1 function. 1 goes to 1 is 1, 1 function. Many goes to 1 is many 1 function. Okay. Also, 1, 1 function is also called as injective function. Okay. One more name for 1, 1 function is injective function. I hope you are clear with this part. So today we have studied only about 1, 1 function and many 1 function. If a function is not 1, 1, that is, if many elements under set X goes to one element in set Y, then it is called as many 1. One element in set X goes to unique one in set Y, then it is called as 1, 1 function. I hope you are clear. Thank you. We'll discuss some more types of function in our next session.